morning, students. Aldehydes and ketones. Right? We were discussing about the preparation. So, can any one of you tell me what we had discussed in the last class? Hmm? Any one of you? Okay. Yes, good morning. What we had discussed in the last class? Just you can put the word. Rosenmund reaction and Stefan reaction. Yes, Sanjana. Only that much. Even we had discussed about preparation. Even we have discussed about preparation of aldehydes and ketones with respect to ozone, using ozone and alkene, right? But anyway, for second PU, it's not much important. Yes, ozonolysis method. Yes. So that's why we have the another method which we had discussed. Okay. But if you remember, with respect to alcohol or with respect to ozone and alkene, in both the cases we can prepare both aldehydes and ketones. We can prepare both the molecules, aldehydes and ketones. May not be same alkene or may not be same alcohol, but what I mean to tell here is alcohol may be of different types, can be converted into aldehydes and ketones. Same way, an alkene of different types can be converted into aldehydes and ketones. So that's why we have the advantage with respect to alcohol and alkenes. Fine, that is one thing. Yes, as you people told, we have discussed about Rosenmund reduction reaction, right? So Rosenmund reduction process. Now can you tell me in Rosenmund reduction how reduction will be taking place? Because reduction can be by addition of electron or by removing of the oxygen or by the adding of the hydrogen. So any of these method can be considered as reduction. In Rosenmund reduction process or reaction, which one we are following? Whether we are removing the, yes, adding of hydrogen. Very good, adding of hydrogen. So that's where hydrogenation. That's where hydrogenation. That is one point which we had discussed. So which is the reactant which we are using in Rosenmund reduction reaction? Which is that reactant we are using? Hydrogen in the presence of palladium catalysts in the presence of barium sulphate. Okay. Krishna, it is not acrylic chloride, it is acyl chloride. Sanjana, why acyl halide came? Oh, okay. You are talking about chloride. Okay, fine. Yes. So in case of the Rosenmund reduction process, reactant will be acyl chloride. Okay. Then hydrogen in the presence of HCl. In the presence of palladium barium sulphate. In the presence of palladium barium sulphate. So that's where the reaction will be happening. And aldehydes will be the product. Aldehydes will be the product. Along with that, acidic condition, that is HCl, will be formed. So this is what the reaction. Now can you tell me, should only chloride be used for any other halide may be used? Any other halides can also be used. Okay. Now next one is, with respect to this particular reaction, one disadvantage is that, which is that with respect to Rosenmund reduction reaction, one disadvantage is there, which is that, can any one of you, which is that disadvantage with respect to Rosenmund reduction reaction? Formaldehyde can't be formed. Very good. Very good. So in this method, formaldehyde cannot be prepared. Formaldehyde cannot be prepared. Why? What is the reason? Because this reaction cannot give. Okay, yes, very good. Due to the instability of the reactant. For the preparation of formaldehyde, we require formal chloride. So that's where, due to the instability of the reactant, formaldehyde cannot be prepared by Rosenmund reduction process. Okay? Now, if you observe it carefully, compared to alcohol and ozone method, in this case only aldehydes can be formed. In Rosenmund reduction process, only aldehydes can be formed. Ketones will not be formed by this particular method. Okay? Fine. Now, why palladium, barium sulfate only? Why not only palladium? That is to control the hydrogenation. That is to control the hydrogenation. That's why we are using palladium on barium sulfate. Not controlled oxidation. That is hydrogenation. Okay na? Otherwise what will happen? It will lead to the formation of alcohol. So we don't want alcohol. Therefore, we want to control the hydrogenation. It's a reduction. Okay, it's not a oxidation. Fine, very good. All of you are attempting. Yes, Brinda, to control the hydrogenation, no doubt. Then along with that, as people told, we have discussed about Stephan reaction. Then we have discussed about Stephan reaction. So which are those reactants which will be used in Stephan reaction? Which are those reactants? Nitrides. Very good, Archit. So it will be nitrides. Then anything else? Or a catalyst? That is stannous chloride and HCl. Very good. Stannous chloride and HCl. Right? So under this condition, which is that intermediate which will be formed? Which is that intermediate which will be formed during Stephan reaction? Aminium. Okay. Aminium or iminium. Yes, imine. We can call it as imine, or we can call it as iminium. We can call it as iminium chloride or halides. Since I have taken HCl, we can call it as iminium chloride or imine. Yes, Brinda, we can simply call it as imines. Will be the intermediates. Okay? Yes, not aminium. Yes, Archit, it should be iminium. Okay, na? So now, what will be the next step? Directly whether it will give rise to the product or some condition we have to maintain. What is that condition? What is that condition we have to maintain in the last step? Yes, very good. We have to go with, anyway, since HCl is there, acidic condition will be there, but I wanted you people to know acidic or acid hydrolysis. Acid hydrolysis. Okay? Now that's where there will be formation of aldehydes. There will be formation of aldehydes. Whether any salt will be formed during the reaction, whether any salt will be formed, anyone? A special salt will be there, which may not be including metal, but there will be formation of ammonium chloride. There will be formation of ammonium chloride. A special salt, because in all the other cases it will be the metal, but here it is ammonium chloride. Yes, Brinda, very good. So that's where we have the Stephan reaction. That's where we have the Stephan reaction, which will be used for the conversion of nitriles to respective aldehydes. Stephan reaction will be used for the conversion of nitriles to respective aldehydes. Got my point? Any doubts with regard to these reactions? Okay, so shall we move to the next one? Now, in the last class, means yesterday's class, we ended up with esters. There was a question from Krishna that, okay, we have discussed about nitriles which will be converted into aldehydes. What about esters? Now, when I am talking about esters getting converted into aldehydes, that will not be coming under Stephan reaction. So, we will consider it separately. Okay, na? So, we will consider it separately. So, when I am talking about nitriles to aldehydes, it is with respect to Stephan reaction. Okay, but there are many other methods. Say, for example, nitriles can also be converted into aldehydes by another method, which is a mild reducing agent, by using a mild reducing agent. Normally, they will use Dibal H. Dibal H. So, what do you mean by Dibal H? Okay, it is a reducing agent. It is a reducing agent. Naturally, when we are converting nitriles to aldehydes, we have to use the mild reducing agent. Okay. So, what is Dibal? Dibal is nothing but diisobutyl. Diisobutyl. That's what Di. Diisobutyl. Okay. So DIP, full form we got diisobutyl, DIP. Aluminium hydride. Aluminium hydride. That's where we have the full form for the Dibal H. Dibal H, I think we have discussed in first PU also, if I am right, with respect to L block, S aluminium, okay, group 13 elements, Dibal H. Just like sodium borohydride, even this can be used as a reducing agent. NaBH4, if you remember, sodium borohydride. In many of the reactions, sodium borohydride will be replaced by the Dibal H. Okay, so diisobutyl aluminium hydride. Anyway, structure no one will ask, but I will tell how it will be acting as a reducing agent. So what is diisobutyl? That means there should be CH, because for that another element will be attached. CH3, CH3. That's where we have the isobutyl. That's where we have the isobutyl, right? So this is nothing but isobutyl. One isobutyl is there. Now two isobutyl we have to mention. So CH2, CH, CH3, CH3. 3. So 2 isobutyl, diisobutyl is there, right? So now they will make the interaction with aluminium. Aluminium can go with plus 3, right? So that's where hydride. That's where we have the hydride. Hydrogen with -1 oxidation state. Do you agree? Hydride will be having -1 oxidation state, hydrogen. So that's where diisobutyl aluminium hydride. If I take this particular molecule, when many molecules of Dibal H they are together, now they can make the interaction in such a way that hydrogen can act as a bridge. Hydrogen can act as a bridge. Anyway, please don't worry about the structure. To make you understand, I am writing this one. So don't worry about the structure and all. No one will ask you about the structure. So that's how it will be present. Similar type of structure in the previous, that means first year we have discussed, where we have discussed about similar type of interaction where hydrogen will act as a bridge. Where hydrogen will act as a bridge, where we have discussed. Yes, banana bond, that is diborane. We have discussed with respect to diborane. Same way, Dibal H will be present. Same way, Dibal H will be present, and they can donate the hydride. They can donate the hydride, and that's how they will act as a reducing agent by donating the hydride. Okay, so nitrile group can also be converted into respective aldehydes by the hydrolysis in the presence of Dibal H. By the hydrolysis in the presence of reducing agent, that is Dibal H. Okay, so hagadre when I am talking about the reaction, naturally we should be taking the nitriles or CN, nitrile. Okay, so when it is added with Dibal H, in the presence of Dibal H, it will be hydrolyzed and there will be formation of RCHO. There will be formation of RCHO. Any other product we can expect here? Please, this much reaction is more than enough, so that it will be helpful for your competitive exams. I am asking, any other product you can expect here? Yes, very good. It is okay. Sanjana BH3 for earlier one. Very good. Diborane B2H6. Okay. BH3 BH3. Yes. Now AG has written Archit, right? Or Arpit. Arpit has written NH3. Yes, ammonia. Another product will be ammonia. Always I will be having confusion between Archit and Arpit. Okay, Arpit. Yes, Archit has given the name as Arpit. Okay. So Archit has told, it is not me, it is Arpit. Okay. So it should be ammonia. Very good. That's where nitrogen is getting reduced. Sorry, nitrogen is getting oxidized because it is attached with the hydrogen. It is attached with the hydrogen. Okay. So what is happening here is, in short, I can tell that it is a mild reducing agent. No elements are getting oxidized or no elements are getting reduced. But we can observe there was no hydrogen here. It is attached with the hydrogen. But please remember, at the same time, oxygen is also added. So that's why I'm telling. It's not like any element is getting oxidized or any element is getting reduced, because dipal is a mild reducing agent. Okay? So that's where we can have another method for the conversion of nitriles to aldehydes. Whether I am clear, there are two methods. One is Stephan reaction and another one is this one, using Dibal H. Okay? For the conversion of nitriles to aldehydes. Now we will come to esters. So once again, esters will be converted into aldehydes. By using Dibal H. Hydrolysis of esters in the presence of Dibal H. Before going to the reaction, what are esters? We have studied already in alcohol topic. And we are going to study once again in carboxylic acid topic. So what are esters? Esters are nothing but a molecule which are having linkage like this. Those molecules are called as esters. COO. Okay. So it is esters. Okay. But anyway, Krishna is written properly only. But others should not get confused. If you write like this, it is carboxylate. It's not a ester. It will become a carboxylate. Okay. So that's where we have the esters. Okay, now? Yes, all of you have written properly. Okay, that's where both of you have written properly. That's where we have the esters. How these esters will be formed? Esters will be formed by the reaction of. Yes, Archit, it will be more safer if you write like that. Yes, esters will be formed by the reaction of carboxylic acid with alcohol. That's where there will be liberation of water. Hagadre, OH and H. So water has been removed. What is left over? R, CO and R prime O. So that's where we have the esters. Okay? When I am talking about preparation of esters, this is where we have to prepare the esters by using alcohol and carboxylic acid. By this background, now I will move to preparation of aldehydes by using esters. Okay, preparation of aldehydes by using esters. Okay, now this is one of the molecule which is ester. Now it will be treated with Dibal H. It will be hydrolyzed in the presence of Dibal H. Now there will be formation of a product. That is RCOH. Aldehyde. Okay. So any other product you expect here? It will be alcohol. Another product can be alcohol. Okay, another product can be alcohol. All of you got my point? Another product can be alcohol. Fine? Yes, both of you correct. Here Krishna has given the answer, that is alcohol. Okay, I will take the example now. CH3, CH2, CO, O, CH3. So this is the molecule. So this is the molecule. Okay. So it is the ester. It's the ester. Okay. So hagadre, what can be the name of this molecule? What can be the name of this molecule? Any one of you? Any one of you can tell me? I have written the molecule on the name board. Can any one of you tell me? Methyl propionate. Okay, very good. It can be methyl propionate. Okay. Hagadre. Now you should tell me the product. That's how the questions will be there. Okay. It will be treated with Dibal H. Hydrolysis. Which will be the products which will be formed? Which aldehydes we are going to get? Which aldehydes we are going to get? Propanol and methanol. Very good. So we are going to get CH3, CH2, COH. So that is nothing but propanol plus CH3OH. That is methanol. That is methanol. Very good. Okay. So that's where we are going to have the reaction. And the product will be propanol and methanol. So what you should remember here is, whichever alkyl group is attached with this carbonyl group, they should be converted into aldehydes by this method. They should be converted into aldehydes. How to easily remember the product? It's very easy. Carbonyl group to which alkyl groups are attached, those respective aldehydes will be formed, and those respective alcohol will be formed. Got my point? So this is how an esters can be converted into aldehydes. An esters can be converted into aldehydes. Okay? So that is the application of Dibal H, which will be acting as a mild reducing agent. How they will act as a reducing agent? By donating the hydrides. By donating the hydrides. Okay? And once again they will be regenerated because they will take the molecule from water. They will be regenerated, no doubt. Okay now? Any doubts up to here? So what we have discussed until now is preparation from alcohol. To avoid the confusion, I am writing. So then preparation from alkenes. Then preparation from, okay, in the same way I will write. Preparation from acyl chloride. Preparation from acyl chloride. Then preparation from nitriles. In the nitriles, we have discussed two types. One is Stephan reaction, and another one is by using Dibal H. And from acyl chloride is nothing but Rosenmund reduction reaction. Okay. So then we have discussed about esters. Once again, it is by using Dibal H only. In this, whatever we have discussed, first one I will mention it as very important because twice it has come. Second one, no problem with respect to your board exam. Okay. Third one, very, very important. And nitriles, from the nitriles, especially Stephan reaction, very, very important. Okay, and rest of the things they may ask or they may not ask. Okay, so that's where we have the importance of these reactions. But you should know what is the ball H, what is the role of the ball H. So that's what we have discussed. Okay, any doubts with regard to these reactions, what we have discussed? Otherwise, I will move to the next one. If you don't have any doubts, I will move to the next one. Okay. So next one is preparation only, preparation of aldehydes only. That is by using chromyl chloride. That is by using chromyl chloride. So this is very important. This is in aldehydes ketones. We have many reactions which are very important, or I can tell this one as very important from chromyl chloride. Okay, so which is nothing but Itard reaction. Itard reaction. Itard reaction, very important one. Okay, so what is chromyl chloride? Chromyl chloride is nothing but CrO2Cl2. CrO2Cl2. So chromyl chloride. Okay, so CrO2Cl2. Okay, so chromium with 2 oxygen and with through 2 chlorine. That's why we have the chromyl chloride. Okay, na? So when I am talking about this reaction, this is meant for the conversion of toluene to benzaldehyde. Itard reaction is meant for the conversion of toluene to benzaldehyde. Whether it is an oxidation or reduction, this reaction, that is conversion of toluene to benzaldehyde, whether it is a oxidation or reduction. I have not written the structure purposefully. Toluene to benzaldehyde, whether it should be oxidation or reduction. Can any one of you tell me? Okay. Yes, very good. Yes, very good. It is a oxidation because we have the toluene, which is nothing but methyl benzene. Toluene is accepted as a name. Okay. So that's why we have the methyl benzene. Fine. So toluene in the presence of chromyl chloride, CrO2Cl2. In the presence of chromyl chloride and in the presence of organic solvents, especially carbon disulfide they will use to enhance the solubility, that's all. So carbon disulfide they will use. Even sometimes we can use ethers also, or carbon tetrachloride, another important reagent they'll be using is carbon tetrachloride, CCl4. Okay, so in the presence of these organic solvents, now there will be formation of an intermediate. There will be, you have to write the intermediate also, or main product you should be appropriate. There will be formation of a intermediate, which is nothing but a chromium complex with the toluene. A chromium complex with the toluene. So CH. Okay, there will be presence of CH. Then this molecule will be attached with the intermediate. That is nothing but O, Cr, OH, Cl and Cl. Same way O, Cr, OH, Cl and Cl. That's where we have the intermediate. But my point, so Actually, this chromy chloride is going to attach to neighboring carbon, not directly here, but there will be rearrangement during the reaction. And chromium will be attacking once again to this carbon through oxygen. This molecule can also be written as in your textbook I will write. This molecule or complex can also be written as plus. So this I think they have written like that. That is also fine. Okay, this is also fine. Okay, na? So in this complex, chromium is not directly attached to the carbon. It is the oxygen which is attached to the carbon. Okay, we can simply call it as chromium complex. We can simply call it as chromium complex with the toluene, or we can simply call it as chromium complex. Fine. Which on acid hydrolysis? Which on acid hydrolysis? Which on acid hydrolysis, that is H3O plus, or we can call it as H plus and water. Anything is fine. So in the presence of H plus, hydrolysis will be taking place. So we can simply call it as H3O plus or acid hydrolysis. Okay. Now there will be formation of benzaldehyde or benzene carbaldehyde. Now there will be formation of benzaldehyde. Okay. So which is the product we were expecting? Benzaldehyde. Okay, now along with that, anyway, side product it's not required, but for your information I am writing side product will be. So here OH, CHO has been gone. So left over will be CrOH, Cl, chromium hydroxychloride, CrOH, Cl, one of the side product which will be released. This is derived from the chromy chloride in the presence of the water. Okay, so that's where chromium hydroxychloride. However, which is the major product we are talking about? Benzaldehyde. Don't worry about this one. By chance, if they ask in competitive exam, that's why I have written. So chromium hydroxychloride. So this is nothing but Isobutane reaction. Once again I will explain. So what is Isobutane reaction? Isobutane reaction is nothing but conversion of toluene to benzaldehyde in the presence of chromy chloride. That is important. There are many methods which can convert toluene to benzaldehyde. But in that, this method is called as Isobutane reaction. So what is that important one? Chromy chloride. So conversion of toluene to benzaldehyde in the presence of chromy chloride. Okay. Now chromy chloride with toluene, what it will make is it will make a complex with the toluene, which is called as chromium complex. Okay, and this chromium complex on acid hydrolysis is going to produce benzaldehyde and chromium hydroxychloride. So that's where we have the Isobutane reaction. That's where we have the Isobutane reaction. Hagadre, in this case, chromium chloride is behaving as. Can any one of you? In this case, chromy chloride is behaving as. Reactant, we know. It's a reactant. It's involved in the reaction. It's not a catalyst. Hagadre, it will be acting as a. Anyone? It is acting as a, chromy chloride is acting as a, yes, oxidizing agent. It is acting as a oxidizing agent. Okay, that's how you should learn the reaction. Then only it will be helpful for your competitive exams. Board exam anyway. If you practice the reaction, if you write the reaction, you will get the marks. Okay, so that's why chromy chloride is behaving as a oxidizing agent because it is oxidizing this carbon to aldehyde. Okay, so that's where we have the reaction. Fine. Any doubts with regard to retard reaction? Very important for your board exam also. This reaction, very, very important. Any doubts? So this is where we have the reaction. Now the question here is whether only toluene should be used in retard reaction. That will be the question. Whether only toluene will be used or any other alkyl benzene can be used. That is the question. Right? Now, very important point here is, anyway, this is not for the board exam. With respect to retard reaction, yes, that is the drawback. Only toluene can be used. Only toluene will be used. Because if you use any other alkyl group, yes, very good. Yes, Arpit. So that's where only toluene can be used. That is because if you are using ethyl benzene, propyl benzene or any other molecules, so that will lead to the formation of other impure products. Means impurity will be there, side products will be there. Say for example, if I use ethyl benzene, now by the ethyl reaction, if you provide the condition, now there will be formation of two products. That is impurity. One is an acetone and another one is our interested product. Okay, so there will be formation of two products. Another step we have to take, we have to make the purity, we have to go for purification. So that's where, what will be the name of this particular product? IUPAC name I want. This one. Okay, acetophenol, fine. It should be N. Acetophenol. Okay, fine. I want IUPAC name. I think we have studied this one. Phenylethanol. Okay, Sanjana, same thing you are doing the mistake. We have to mention the number. So, 1 phenyl, but still I appreciate. So, 1 phenyl, ethan, 1 one. This should be 1, not 2. This carbon should be first carbon because it's a ketone. So, 1 phenyl, ethanol, directly you can write, or 1 phenyl, ethan, 1O. Ethan, 1O. Okay, so 1 phenyl you have to mention because phenyl group can be present over here, it is not possible still. Okay, so therefore we have to mention the number. Phenylethanol, okay, fine. So what about this one? What about this one? Two phenyl ethanol. Okay, very good. So it will be 2 phenyl, very good. 2 phenyl ethanol. Because 1, 2 numbering should be, preference should be given to aldehyde carbon. Very good. 2-phenyl ethanol. Sometimes they will call it as 2-phenyl acetaldehyde. Don't get confused. That is also fine. So 2-phenyl acetaldehyde. That is also fine. 2-phenyl acetaldehyde. So please remember this one. I am not talking about your board exam. They will not ask this one for board exam. Don't worry. Okay. So that's where we have the side product will be there. Equal amount it will be found. That is the problem. No major, no minor. No major product, no minor product. Right? Same problem with respect to propyl benzene or any other alkyl benzene. That is the problem with respect to Itard reaction. So that means Itard reaction is meant for the synthesis of benzaldehyde only. Okay, it is meant for the synthesis of benzaldehyde only. Naturally, when I am telling benzaldehyde, it should be toluene only the reactant which will be utilized. Okay? Any doubts with regard to Itard's reaction? Any doubts? Okay, fine. So, chromyl chloride we have mentioned. Now using chromic oxide or chromium trioxide. So, chromic oxide or chromium trioxide. Anything is fine. Or chromium trioxide, naturally CrO3. So chromium with 3 oxygen. Chromium with 3 oxygen. Chromium trioxide. Okay. So hagadre when I am talking about this particular reaction, once again the toluene is the reactant. Toluene is the reactant. Toluene is the reactant, no doubt. That's what I told. When it comes to conversion of toluene to benzaldehyde, we have methods, many methods. Not only Itard reaction. We have many methods. So for Itard reaction, you have to mention chromyl chloride. Okay. So in this case, we have the toluene in the presence of chromium trioxide or chromic oxide. Now, another reactant is required, which is nothing but acetic anhydride. Which is nothing but acetic anhydride. This is not important as that of the Itard reaction. Okay? But they can ask. So, what is acetic anhydride? Somewhere we have discussed acetic anhydrides. Can any one of you? Where we have discussed acetic anhydride? Wow. Acetic anhydride. Friedel-Crafts reaction. Yes, in Friedel-Crafts reaction. That is with respect to acylation only. Okay, na? That is with respect to acylation only. Now, why it is called as acetic anhydride? Because we have acetic acid. Okay? So, don't worry, this is not for your board exam. We have acetic acid. When they react with each other, when you provide the condition, when they react with each other, now there will be formation of CH3CO, O, CO, CH3. This is nothing but acetic anhydride. It is called as anhydride because during its synthesis there is a removal of water. Therefore, it is called as anhydride. Archit, whatever he had written, it was correct, I think. It was correct. From here I saw whatever he had written, it is correct only. So why it is called as anhydride, I am writing here, that's all. Don't worry this part. This is not for your board exams. This is for your knowledge, information. Okay, na? So that's where we have the acetic anhydride. Yes, dehydration of 2-carboxylic acid. Since I am telling acetic anhydride, I have to take acetic acid. Okay? So therefore, this molecule, either it can be written like this, it can be written like this, but if I want to write like this, it is a time consuming process. So therefore, very simple one is CH3CO twice O. CH3CO twice O. So that's how we can write acetic anhydride. So this is acetic anhydride. Okay. So this is chromic oxide or chromium trioxide. Anything is fine. Chromic because chromium is in its highest oxidation state. So chromic oxide, ferric, ferrous, same way. So chromic oxide, acetic anhydride. Okay. Now, important point here is we have to mention the temperature. We have to mention the temperature. That is because it will be almost 0 degree we have to maintain. Okay. So nearly, or we can write 0 to 5 degrees Celsius. That is important. Whenever temperature plays the crucial role, you have to mention that one. 0 to 5 degrees Celsius, or approximately, if I want to tell it in Kelvin, 273 to 280 Kelvin. 273 to 280 Kelvin. That's very important. Whenever this cold condition or high temperature and all it is there, especially cold condition, whenever it is mentioned, we have to talk about that particular condition. Okay. So now, once again, there will be formation of an intermediate. There will be formation of an intermediate where acetic anhydride is going to attach to the side chain alkyl group. Acetic anhydride is going to attach to the side chain alkyl group. Okay. So how many molecules can be attached? 2 acetyl groups can be attached. Right? So that's where we have the O, then CO, CH3 twice. O, CO, CH3 twice. Okay? So that's where it will be attached. But my point? Any doubts with regard to this one? Same as that of earlier, where chromium complex is there. Same as that of earlier one. So we have CHO, CO, CH3, CO, CH3. One and all same. It is one and all same. Okay. Now this particular molecule is called as benzylidene diacetate. Why diacetate? You will come to know by seeing this structure. So it is nothing but acetyl group, acetate, right? So what is acetate? CH3, CO, CO minus, O minus. That's where we have the acetate. So therefore, since 2 acetyl groups or acetate groups are there, diacetate, benzylidene, CH, okay, benzylidene diacetate, intermediate. Benzylidene diacetate as the intermediate. Okay? Any doubts with regard to this one? Any doubt up to here? If you have any doubts, you can ask. So benzylidene diacetate. So diacetate, you will not understand when you see this one, but it's clear about here. Why it is called as diacetate. If you have any doubts, you can ask until here. So final step here is acid hydrolysis. Both the things will be there. In some cases, they have mentioned alkaline hydrolysis. In both the cases, it will give rise to the product. So I will go with the textbook. Acid hydrolysis. The product will be once again benzaldehyde. Okay, so product will be benzaldehyde. Product will be benzaldehyde. Any other products you can expect here? Along with benzaldehyde, any other products? Chromium oxide, Sanjana, it will act as an oxidizing agent, which we have studied in alcohol, PCC. Okay? So it will act as an oxidizing agent, chromic oxide. Oh, you can write it on arrow also. Yeah, you can write it on arrow also. Okay? So that's why we have the chromic oxide. It will act as an oxidizing agent. Now, when I am talking about another product, as the people have written, acetic acid. Very good. 2 molecules of acetic acid. Since we are going with acidic condition, 2 molecules of acetic acid. If I go with alkaline condition, then sodium acetate. If I go with alkaline condition, it will become sodium acetate. Since I am going with acid hydrolysis, here it is acetic acid. Okay? Sanjana, you got the point. Chromium oxide is acting as a oxidizing agent. It helps in the formation of that intermediate. Mechanism we will not discuss here, but you can remember this one as oxidizing agent. That's all. Okay, na? Any other doubts? So this is with respect to conversion of toluene to benzaldehyde using chromium oxide or chromic oxide or chromium trioxide. Okay? So we can see chromium is in highest oxidation state. So naturally it will act as a oxidizing agent. Okay? So any doubts with regard to today's reactions? Ethanol reaction is very important. This one fine. Okay. But ethanol reaction is very, very important. If you have any doubts, you can ask. In aldehydes and ketones, please practice now itself. Many reactions you will come across and many of them are important also. Okay? Many of them are important also. So you have to practice daily basis. Okay, then I will stop here. Take care. Bye. Thank you.